really fun for me if you do this with me now. So if you have your computer, you can open it and do. It will be so cool. Like I create 3 smart contracts now, and we can really do the cross-chain NFT with me. We are minting an NFT from one chain in another chain. So this is me. My name is Solange Gueiros. I am a developer advocate at Chainlink Labs. You can call me Sol. It's easy. And these are my contacts. Also on my website, I have all my past presentations in Portuguese, English, and Spanish. It's a lot of content that you can have fun. And if you'd like to do with me this, we must have this now. This is our Wi-Fi password. And I just create a document that I can share the information with you. And I can interact with you, you can interact with me, because this is a collaborative thread that we can write together. So I'm going to the pad now. You should be here like me. Is the URL I here as well. So if you are here, could you add here your name and where are you from? So I'm from São Paulo, Brazil. And you? Are you here with me? Yes! We have Matthew, we have Robin. Welcome, welcome. So good to have you working with me now. We'll have fun together. Amazing. Let's come back to my presentation. And if you like to have my presentation, it's here. I know that I have other QR codes in the middle, so get this now and don't worry about the rest. I think we are good now. Okay. So also we are here in Denver because of ETHDenver as well. So we have some bounties in the hackathon, and we have 20,000 bounties in 2 tracks. One is CCIP, that is 2,000 for the best for projects and 2,000 for the project that is using USDC with CCIP. I did a workshop over there Sunday, exactly with Avalanche as well, where I transferred USDC from Avalanche Fuji to Ethereum Sequoia. And I really enjoyed this. It's so cool that now we are doing this with real tokens. And also, if you'd like to use the other services, we have a lot of services that are deployed in Avalanche as well. So 2,000 for the best 5 projects. And this is, what's an Oracle and why I'm here? So Oracle is any kind of data source or external resource that you can use. For example, the temperature or some information from a satellite, or even the information from my watch, that my steps, and I can interact with this, or related to sports or weather, and a lot of financial information as well. And we are talking about, when we talk about oracles, the best is to have a DON, a decentralized oracle network. Because oracle, it's any network or any device that interact with the external world and bring the information to the blockchain to use inside your smart contract. But if you have a centralized source that is getting this information, this is a big risk. This can be compromised, can be manipulated. But when we have a decentralized oracle network, you can have more security that this will be in a right way, because we have a consensus in every information that we get it. And this is Chainlink. Chainlink is not only one, but a set of decentralized oracle networks for different services. We are a Web3 platform, so we have data feeds that you can get codes, and we have the data streams. The difference that the data feed, we have the codes updated in some time. For example, I'd like to get the code of Bitcoin USD in Avalanche, so I can have this information. But imagine that that information will be updated when the price change like 0.5%. But I'd like to have this information now. So I will not use the data feeds, I will use the data streams to get the information exactly in the moment that I need. This is the difference between the push Oracle data feed and the pull Oracle data streams. Also, I'm here to talk about CCIP. This is the connection between the blockchains. So I really believe that we must have the internet of blockchains, all the blockchains connected. Blockchains, we have different blockchains, they have different purpose, and they are so good. We cannot expect that one blockchain can do everything. So it's so important to have this kind of communication. And we have functions. Functions is to connect with the information that is not in a blockchain. Imagine that you'd like to interact with some API in Web 2. You can do this. The API is centralized, but you can get a lot of nodes, some set of nodes that is getting the information for you, and then you have a consensus of the information before bringing it to your smart contract. And also we have VRF. I love to do VRF on Avalanche Fuji because Avalanche in general, but I used to testnet, so the Fuji because it's so fast. And fun thing, when I did a raffle, it was the Avalanche Summit in Barcelona. I did a raffle and supposed to like get one number per minute, but I forgot to update the minutes. And then I got like 5, 6 numbers per minute. It was so fast. It was really fun. And also we have automation that we can interact some calls to your smart contract. The smart contract itself, they cannot call alone. The smart contract will not call a function without an external agent. The external can be you, or can be a decentralized Oracle network that is doing the automation part for you. We have this. And the proof of reserve, imagine like a comment related to USDC. So USDC must have a collateral, must have this outside of the blockchain. So we can prove that they have some dollars. We expect more dollars than USDC. And we can check this out using the proof of reserve. So is this. We are ready to go to the CCIP part, and by the way, we are in different blockchains. You already have the QR code of the presentation, but you can check all the information in our developer portal. And let's talk about CCIP. So, what we are doing today? We are starting here. Fuji will be the source blockchain, and we are creating a smart contract here. This smart contract, you send the mint command to other chain. This smart contract, you interact with a router. So every chain has a router, a smart contract made by Chainlink to receive and to send messages. So we are sending here a message that will be a call to an NFT. And the destination chain, I'd like to, the destination chain will be Sepolia. And this router, you interact with the CCIP network. In fact, it's not only one network. We have 3 networks off-chain. This is the off-chain part that doing this. I will explain this later. And when this is done, it's ready to receive the message on the other side. We have a router in the other side that when I transfer USDC, for example, this can go directly to my wallet. But because I'm interacting with a contract, I'm sending a message, the messages cannot be sent directly to an external account, must send to a contract in the other chain. So I have here a destination cross-chain. It's a contract prepared to receive this message, compatible with the CCIP to receive the message. And this contract is minting the NFT for me. So we are creating 3 contracts now. First, the source contract, then the destination contract and the NFT. And is this, when we talk about the cross-chain part, we are here, especially we are talking about message that can be tokens, can be like hello Avalanche, and can be tokens and the message. And imagine that if you send some token to another chain, you can do something with this token, like use the token like a collateral, something like that, or borrow, or whatever you'd like to do. I will come back to the explanation later because I'd like to start the hands-on part. So let's do it. First of all, remember that we are here, so we are going now to remix. So you can go to remix, and before that, be sure that your, and I'm using a MetaMask wallet, so be sure that your MetaMask wallet is on Avalanche Fuji. I don't know if mine is, let's see. Yes, I am here. And you must have link on, you must have, here you must have a bit of Avalanche Fuji and the link in order to do this. Yes, thank you. This is amazing, you are helping me. I used to do this like in another way as well, because if I came here and click directly here, you can do directly in this way, and then you have Avalanche Fuji in your MetaMask wallet. Who needs tokens? Do you have tokens? Do you need it? Okay. No? Are good? Okay. You can go to the Chainlink faucet as well, faucet.chain.link, and get some tokens over there. If you need only the link token, I can connect now. You don't need to do nothing extra, it's so easy. Maybe if you are in the same network, only one person can do this, but if you do like, I can send to you, I have a lot now here, and you can get the 25 test link. This is the difficult part for me, verify that I am a human. Okay, I know this now. Let's go forward. Okay, yes, now we can go to remix. So our first smart contract is the source minter. I'm creating this for you and I'm sharing where I have this. So this is my first contract. And so create the cross source minter. And it's here, the source code for you, okay? And let's understand what we have on this contract. This is better. It's here. Okay. I must let you know that we are creating this now, but we can't deploy it now because we must have the destination part done. But let's understand what's happened here. So I'm interacting with the router. So here is the router client. Each chain has one router, one smart contract that I'm interacting with. Then I'm importing the client library. This is because I have some structures, some custom information that I must fill to be compatible. And when I'm doing a cross-chain something, I must pay fees in the other chain. But I will pay all the fees on the source blockchain. So I'm paying fees here, now, on Avalanche Fuji. These fees will be calculated by the router. Depends of the destination chain and the message. Like to send a token, it's cheaper than to use the main function, for example, or to send things to Mumbai or to Avalanche Fuji is cheaper than to send to Sepolia, things like that. So depends of my message, depends of the destination chain. Then here I may like take care of some errors. I must send the link to my contract to pay the fees. I can pay the fees using the link token or using the native token. So I can pay the fees using Avalanche Fuji. I used to pay on link, and here I'm paying on link, but you can pay with both. And because I'm sending link to my content, at the end, if I'd like to withdraw my link again, I can. So this is all the variables that we must have. And on the constructor, when I'm creating the content, you can see here that I must have the destination minted. It means that I must first create this in the other chain, and then we are come back here. But I'd like you to understand this part first. So because this is from Fuji, I'm interacting with the Fuji router, and this is the link on Fuji. I already approving the router to use my link from here, and I'm going to Sepolia. So the destination chain is this from Sepolia. Where I get this information? It was here. If I go here, you can see all the supported networks. So we are here on Fuji. This is the router. This is the link. I'm paying link. I can pay in AVAX as well, in Rapid AVAX. And I'm going to Sepolia. This is what I can do on Sepolia, the links that I can transfer. In fact, I'm not transferring tokens now. But remember that I'm arriving, my destination is Sepolia. So I'm using this chain selector to arrive on Sepolia. Okay? Let's come back here. And here I'm initializing everything that I told you. And remember that we must deploy the other content before that. But this is the amazing function that I love, mint on Sepolia. Remember, I am on Fuji. And here I remember that I told you related to the structure. So the EVM to any message, I'm creating the message. The receiver will be my smart contract in the other chain. Also, I have in the data, I have what is my message. My message is the mint from function. This function will exist on my NFT. We are creating the NFT soon. And I'm minting from myself, I'm sending the transaction, the user who is sending, and the one is over there because I have a list of chains, and on my list, one is Avalanche Fuji. And this is, I'm increasing the gas limit because I needed an extra gas limit. If I'm only doing token transfer, I don't need it, but here I need it. And I'm paying the fees using the token link. What more I have here? Here, remember that I told you that the router is calculating the fees for me, is that? So I must have the chain selector and the message to get the fees. Then I must be sure that I have enough link on my contract to pay the fees. And this is, I can send the message. Remember that I told you that if at the end I'd like to withdraw the link, I can. And because I created this link balance function only to facilitate my life when I am interacting with the students to be sure that they are right. Okay? This is the cross-source minter. We can't do this now, so let's do the NFT. To do the NFT, I must go on my MetaMask now on Sepolia. It will be the destination. So on Sepolia. And I will create first the NFT. Let's get it. Bootcamp. I did this bootcamp in January, so this is the cross-chain price NFT. And probably, maybe you are a bit curious related what is this. I can show you. This is the code. And this is the name. Let's go over there. This. Okay, we are creating this file now. Okay, the file is here. And what I have here, let's understand this NFT. And I'd like to get the last that I did. It's around. I will get in a minute. I'm curious, wait. Here. Let's see the last. This is the cross-chain price. So all of this was minted on Sepolia. But if you came here, all the red are from Avalanche. I did some on Mumbai as well. We have a lot here. And what is happening here? Why these guys are so happy? One thing that I really like on this NFT collection is that this is an SVG, an image that I'm generating inside the smart contract. This is not something that I have outside. I generate everything inside. So I have the emoji, and the emoji is based in the last time that I interacted with my content. So if the last time I'm comparing the prices and I'm using the Chainlink data feed to do this. So if the last time that I minted an NFT, the price now is higher, I'll be happy. If the price now is low, I'll be sad. If the price is the same, it's neutral. Is this. And the background is related to the chain that I'm minting from. We are doing this now. A new one from zero. Okay? So let's do. We can create the NFT. I'd like to explain a bit more of the NFT because this is the price indicators, the emojis that I have it. This is the chain structure that I created. So the chain 0 for me is Sepolia is blue. The chain 1 is Fuji. The chain 2 is Mumbai. And this is the price aggregator because I'm minting on Sepolia. I got on Sepolia. But maybe I could get the price in the Cersei blockchain as well. It's possible. Maybe I'll do this in the next version of this. And I'm minting the first NFT. After this, I have the mint function. The mint must be in the chain that I am. So if I'm deploying this on Sepolia, the mint is from 0 because it's Sepolia. But we are using this function from Avalanche Fuji because I'm minting from 1 that's Fuji. And remember that I told you that we are updating the metadata, the JSON file that's compatible with the OpenSea, for example. I'm updating this on-chain, so my JSON file is on-chain as well. I'm creating this here, name, description, image based on the final SVG that I will generate. And that attributes will be, first, the last price, and then this here the price, and here the chain, the source chain. Here I'm building the SVG, so I get the price, comparing the price, and also you can see here that I'm using the background color. So is this, if you'd like to do this with me now, let's deploy. I think I didn't change my network. Yes, I am on Sepolia now. So deploy it. No, I did something wrong. Yes, I didn't connect my wallet yet. Now I am connected. Let's deploy. And if you are doing with me, we can add here your name and your NFT address. This is mine. You can interact with mine as well. Yes, I have it. So this is mine. This is the NFT itself. So if I go here on testnets OpenSea, I can find this. And I used to copy and paste everything in the pad, so you can do this as well. Probably I must wait a bit more to OpenSea find my NFT, or I can force OpenSea to find it. If I get any of these, imagine that I have one NFT, this is the index 0, but I'd like to have this address. So I change the address here. And this is my collection. And I can go here. This is my collection that I just did now. I can add this for you as well. Okay, we have the collection. Now I must have another smart contract on Sepolia prepared to receive my message. Let's do this. Now I will create this cross-chain destination minter. Let's be prepared to receive the message. So create this, let's get it, I'm here, Probably I already have it. Cross-chain destination minter. Here we are. So this contract will be prepared to mint my NFT. So I must have my NFT address. Let's go. I'm here and I must have my NFT address. First of all, let's understand this contract. So here it's an important point. I have this CCIP receiver. I must have this in order to my contract be prepared to receive the message. So I'm importing the CCIP receiver. And also the same client to understand the message. I could import all the interface of an NFT, but remember that I have a function called mint from. So I only using this function now. This is the cross-destination minter. So I'm using this on Sepolia, so the CCIP router on Sepolia is that. I'm initializing with the NFT address. And if you are interacting with CCIP, if you are receiving a message, you must have this underscore CCIP receive. Like the router, you look for this function inside your contract. And really, I'm only getting the NFT address and calling whatever I have on my message. What I have on my message, do you remember? The mint from. Yes? So if you come here, my message is this. This is my message. So this message, you'll be sent to this address. You'll be here. And this is, I have some tests to do in the same chain to be sure that this is working. I don't need to do this now, in fact. And I was doing the same contract with different NFTs, so I was updating the NFT in the past. So we are ready to deploy this as well. Copy my NFT address. This is the parameter, so paste it and deploy. Confirming. And let's wait appear here. If you'd like to get mine as well, if you'd like to interact with mine. So is this my address is done here. This is mine. You can interact with mine as well. So now that I have here, I can come back to Fuji. And now I can deploy the first contract that I have here. So I will deploy this now. Let's come back on my MetaMask wallet to Avalanche Fuji. Yes, I'm here. In Remix, let's be sure. Yes, this is the ID of the Avalanche Fuji. You can see here the same ID. Okay. And now to deploy the minter, I must have my destination minter. And I must open the cross-source minter again. Now I am in the cross-source minter here, and let's deploy it. Yes, it's so fast. I love Avalanche. So here we are. This is mine. If you'd like to interact with my content, you can get my address directly and use the ETH address on Remix. It'll be good. And okay, my contract is ready to do this. No, it's not. Why not? Remember that I must have a link inside my contract to pay the fees. So let's send the link. Send the link. Send 3 links. Your contract. Let's do it. This is my contract. I'm here now. So tokens, I already have the link here. Send my contract address. 2, 3, I don't remember how many, 3. Even 1 is enough now. So when this is done, I can check, okay, so fast. Copy, let's get my link balance, the link that I have in my content. It is still 0, not because it's not confirmed. It's 0 because there are some delay in the communication between the MetaMask and the remix. It's still, but I can see here that it's over there. I send it, okay? 3 links. But now I'm ready to do the mint on Sepolia. Remember, I am on Avalanche Fuji. And when my transaction is confirmed, is already confirmed, I can see this is my transaction ID. So we are doing the mint on Sepolia. Mine is, let's get mine. Go to MetaMask, contract, copy transaction ID, paste here. But I'd like to see this on the CCIP Explorer. Let's paste this for you if you'd like to follow me. Here we are. Not yet. I lost my transaction. Yes. You can see that the source hashes this. We don't have the transaction, the destination yet. It's blessed. It means that the source was finalized. We know that in AVAX this is so fast. And now the blessed means that the security risk network is analyzing my transaction. And you can see the cost over there. And this is a good moment to come back to my slides to understand what we are doing here. So here we are. This is the cross-chain message. We have a message to send the mint function. Remember that the CCIP sender can be an external account and can be any smart contract. For us, it's a smart contract that we deployed on Fuji. The receiver can be an account if it's a token, but if it's a message, must be a smart contract that have the CCIP receiver. We have it. The router is the contract responsible to do the interaction. It means that you receive a message in one chain, you send the message in the other chain. Each chain has one router. And what can I do with this? You know that you can token transfer, you can send the messages, hello Avalanche, and we can do something combining both of these. And these are some examples, like use the token in one chain to another chain being a collateral. NFTs, we are doing this now, working with the NFTs. Imagine that, think about the account abstraction. We can have some smart contract that is interacting with wallets in different chains, or games that can be already, you have a weapon in one chain and you like to use in another. And imagine about data storage or computation, like it's cheaper to do this on Avalanche, and you can do heavy computation here and using another place. Everything can be possible now between chains. We are talking about the internet of blockchains. And it's this, we did this now, woohoo. But I'd like to explain a bit more. So when I'm doing this, minting an NFT from one chain that appear in another chain, we are doing this. Another approach, I could have the same NFT in different chains, and then I can have like the status, it's active on Fuji or other chain, and I can change the status, I can change the color, I can change what I like to have with the same NFT that I can have minting different chains. It's another approach that we can try by yourself. So this is the message that we are encoding. I'm sending only one command, the mint from. But imagine that I can send mint multiple commands to interact with different contexts in the destination chain. This is possible as well. And we already talked about the fees. Remember that we are paying the fees in the CCIP blockchain. Okay. And we did this now. This is the order that I have. I'd like to interact with this as well. Oh, let's come back here. Because I did this before, maybe you have different results on this. Let's have one more contact here. It's the same cross CCIP minter, but I will use the AT address to create a new transaction here as well. And probably the order is done. So I'm creating a new transaction and I'd like to see what's happened here. I must update this, I will not wait. Yes! So it's done. I minted one NFT starting on Avalanche Fuji. The NFT will appear on Sepolia. Oh, let's see. It was not this, it's this that I create now. Remember, I have only one. Now I must have another red. I don't know if it's happy or no. Let's see. Oh, it's flat. It means it's neutral because the price in the testnet is not updated so often like the mainnet, at least on this. But we can go over there. Let's open it and see. This is the price now 61,200 something. This is from Fuji. If I come here, I can see that it was minted 4 minutes ago. We are good on this. And you saw that I did an order. I'd like to see the order. Let's go to my MetaMask wallet again. Get my last transaction. Yes. 1 minute, I'm almost finishing. Okay. Yes, so here we are, the order is done as well. So if I came here, the old one that I have it, maybe the price changed it. Let's see here the recent listed, and then we can get the last one. It's happy, you can see that's happy now. And let's compare with the order. We did this now. You can see that 45 seconds ago, the order was on Fuji as well. It was like 3 days ago, and the price went up. Amazing. And almost finishing, I'd like to only talk about this with you. I have like 2 slides more for you. You must understand that we don't have only one network. We have, in fact, 3 networks that take care of this. When the transaction is sending to the other chain, the committed is the commit done that sends the transaction, but you're not executed yet in the destination chain. The risk management network must check the transaction to be sure that nothing's wrong. And only after that, that blessed that you saw, you have the executing done that you do the final part of this. And this is the risk management network. And I thought that I have 1 hour. I only to finish, I'd like to invite you, we have another bootcamp online starting on 1st of April. After here, you can like take a break and you can be with us again. I did this in January in Spanish, Portuguese and English. Now we have Turkish, we have more language. Probably we are inviting the Avalanche guys to talk with us, to teach with us. We are talking about this. Be prepared. And this is my presentation. Do you have any questions now? Yes.
So the example you just gave of minting on multiple chains at the same time, in essence, that was in testnet. Does it also work in mainnet?
Yes, exactly. The only thing that you must change from a testnet to mainnet is go to the supported networks like this and check it out what you have on mainnet and change the address. Exactly. When you add a transaction over there, Data Explorer, you look for which chain is that transaction, and then they can mount that part for us.
And is that for every transaction on the chain, or only things that you do through Chainlink?
Only with the CCIP. This is the CCIP Explorer, so we can only check the transactions that are doing using the CCIP router. Yes.
So how do you calculate? So like when I send a message to another chain, right?
Yes.
The sending chain has to pay the gas fees that would result in
Exactly.
10%, right? So how are those gas fees calculated, right? Do you simulate what's going to happen with the transaction on the receiving chain?
Yes, exactly. This is what the router do. So when I came here to the cross source you can see over there that here I have this get fee, and it depends of the destination chain and depends of the size of your message, but this is it's simulating, and then you'll be executed. Once I have a problem that didn't arrive in the other chain, but the gas price changed a lot, and then you do like a manual execution. You can do this as well. But it was only once.
Yeah, that's just kind of what I'm concerned about, because it seems to me like you can, right, in Ethereum, you can construct a contract in such a way that most of the time when you simulate it, you'll have a low gas price, and that's okay with this, but then, when it's every, whatever, you'll get like a huge bill, and you might get charged like, underneath or whatever.
Exactly.
So I'm just wondering like, how you hedge against that.
Yeah, you can try to build a contract like this because you can use the get fee to get the best moment as well.
Is that interface that you're showing for minting, is that something that you built, or is that like for your purpose, or is that something that is general purpose for other users?
Are you talking about this? Like this?
No, the interface that you were using to mint the tokens?
Because I mint the tokens using Remix. Remix is an environment to deploy contracts, and this is made by Ethereum Foundation, but you can connect with any wallet, and if your wallet is on Avalanche Fuji, for example, I'm connecting this wallet now and I'm interacting with that chain. So this is an application, for me, is the best application to beginners. When you have like a complex project, you go like to a Visual Code, do something local. But when you are like here, like you can copy and paste and do this with me without install nothing more in your computer. This is so cool. I love this. What more? More questions? So, all right. Again, I think you got the presentation. This is me. And I'd like to say thank you. See you around.